Hi, this is Shakrazar, and in this video I'm going through the homework 2 in the deep learning course. This is the Python file provided by the professor, and we need to make some modifications according to the professor mentioned in the homework to get the desired output. So yeah, when it comes to the evaluate function, initially it calculated only the correct count. After the modification, we have we have added some more metrics like accuracy, likelihood, cross entropy, and the mean square error. So yeah, uh, yeah. In order to calculate the several error metrics, I'm zipping activation and the actual output values, and for every iteration I'm calculating the errors as per the mathematical equation. So here you can see that the test square error is difference between the activation and output, and for the test MSE, for the mean square error I am taking the mean of all square errors we have computed, and for the cross entropy it's the same as per the mathematical equation, and I have taken the mean value. And for the likelihood, uh, here I had to add one more point. Since the output is a hard vector in notation like 0 1 0 like that, I'm taking only I'm multiplying that vector notation with the activation values, so that the output with the activation value will the activation value for the desired output 1 will be there and remaining will be 0, and at the end I am taking the mean value of it. So in this way we calculated the several error metrics, and we are returning those values here. And when it comes to the std function, I'm printing all of the results we got from the evaluate, and if the test data is not present we won't do it, or else it will or else we will print the results of both train and test. And here I'm concatenating the train and test results into this list, and if the test data is not present the empty list will be appended, or else the list will be appended. And at the end we are returning these values, returning those results list into a one list. Combining that into one list, and then we are returning it. Here you can see the list stopping method I have added here. So if the accuracy increases beyond the particular accuracy we have mentioned, the epochs will be stopped prematurely. And coming to the back propagation, here I have added the activation, same like the biases here, but I am considering the input layer 2. Where is it? Yeah, input layer 2. And I have added the first input layer to the activations of 0, the first element in the activations list. And for every iteration, for every activations value we are appending it to, we are updating the values to activations here. And here we are printing the activations value, and later we commented as per the professor mentioned. And going to the homework 2, the implementation file, here we can see after we implementing the modified functions we got the same output values as per the professor mentioned here. So it shows the code is working correctly, and here I have checked the stopping criteria too. 0.6, 0.8 and 0.0 all are getting the same results. And here is the deep network, and in this function too we got the same values as you can see it here. And I have implemented the extra grid here, and here I am visualizing the errors into your plots, and here you can see all errors are decreasing as per for every iteration of the epoch, so it indicates the good performance of the network. And here you can see the test and train MSEs, which these are very close to each other, so we can say that the network is not overfitted to the training set. uh, Thank you.